Let's talk about nitrile hydrolyses. All hydrolyses are simply adding water. Before you consider the mechanism, get a good idea of what's happening. Just do a simple addition. We're going to add this water across the triple bond and see what happens. When we do that and draw everything in the same orientation as when we started, always a good practice, then we get a weird, distorted type of compound that we don't recognize, but we don't make any mistakes about where the hydrogen and the OH went. And then consider redrawing that in a realistic way. And this is what we get. It still doesn't look quite like the hydrolysis product. We want to form an amide. How do we get there? Well, we simply tautomerize. We take a hydrogen that was downstairs on the oxygen, and we put it upstairs on the nitrogen. And there's an amide. You can recognize that now. What's the mechanism? That's important because I think if you know the mechanism, it's harder to forget the process overall. First, protonate to activate. That's a great thing to remember whenever you're looking at a mechanism in acid. The acid is usually there for a purpose. It's going to protonate something, and when it does, whatever the product is, or whatever the intermediate is, it will be more reactive. So protonate to activate. Where is the most basic site on a nitrile? It's the nitrogen, and that's where we'll protonate. And if we want to give the product a name, it's a nitrillium ion, or simply a nitrillium. IUN stands for positive. Ammonium, phosphonium, carbonium, nitrillium. They're all positive. Now, when we add a nucleophile, we can't add it on the nitrogen because we've already got 4 bonds there. It just doesn't fit. The nucleophile is going to add to the carbon, and the electrons are going to feed into the nitrogen. Nucleophilic attack of water. Let's see how that works. The water approaches, you put your pen where the electron density is, push towards the carbon, and the electrons on the carbon are displaced onto the nitrogen. It's like dominoes. One knocks over the other. So we form this cationic intermediate. Finally, we're going to deprotonate to the product and then tautomerize. So here's the product that we had in the last step. Let's deprotonate. You can show a base taking this off if you want to, but remember the strongest base you've got in aqueous solution is probably water. So water comes in and deprotonates if you like, or just lose the proton. And when you do that, we get something strange. It doesn't look like an amide. It's actually an imidate, but we're going to tautomerize that. And when we do, the keto form is the amide that you would recognize. In that tautomerization, we've taken a hydrogen that was downstairs, and we've put the hydrogen upstairs on the nitrogen to give us our product. That is the story of nitrile hydrolysis. Thank you very much for listening, and good luck with your studies.